Good afternoon, everyone. Welcome to the Pulumi and Armory webinar. We're going to get started in a few minutes here. We're just going to take a few moments for everyone else who registered to join. In the meantime, we have a few poll questions we'd like to ask you and get your answers from. All right, so we have both some new users as well as people who've been using Pulumi for a while. That's great to see. All right, I think we have another poll question for everyone. And this one is, what's your favorite Pulumi superpower? All right, so it looks like within the audience, seems like there's pretty solid usage across the board of various Pulumi capabilities. So I have a few other questions here. I'll pull up one last one and then we'll get started. All right, so how much experience do you have using Spinnaker? Are folks here new to Spinnaker, or is this something you've been using for a while? Would love your feedback. All right, so it looks like there's a good number of you are ready to have your minds blown about how awesome it is to use Spinnaker with Pulumi. And with that, I'm going to turn control over to Daniel and let him kick things off.
Hi, everyone. I am Dan Peach, software engineer at Armory. I've been working in the Spinnaker community for about 4 years and super excited to be here to talk about Pulumi and Spinnaker.
And I'm Praneet Loki. I'm a software engineer at Pulumi. I work on our SaaS platform, and I especially like working on CI/CD integrations. And I actually worked on the Spinnaker plugin for Pulumi with Daniel Peach at Armory.
Cool. As Praneet mentioned, we're going to be talking about sort of the plugin that Praneet made for Spinnaker, but just sort of at a high level, we're going to talk about sort of how CD tools and infrastructure tools can work together, and how sort of we can take the best concepts and best practices from application delivery and apply them to infrastructure changes. So you can imagine like canarying changes to infrastructure rather than rolling out those changes monolithically. Another side of this is infrastructure tools can help in the whole CD process. Things that can be hard to do in a CD tool, like setting up ephemeral QA or test environments, are easy when you bring CD and infrastructure tools together. CD tools like Spinnaker usually don't know about, say, SQS or your S3 bucket, but Pulumi does. What is Spinnaker? It's a continuous delivery tool. It was open sourced by Netflix and Google in 2015. Because it's open source, it has a huge set of integrations, usually built by the cloud vendors themselves. When it was open sourced, it was like really a tool for deploying VMs to EC2 or Google Compute Engine, and it's expanded so much now. So there's a Cloud Foundry provider, an App Engine provider, a Kubernetes provider, and so on. Sort of the shortest path to understanding Spinnaker and what sort of separates it from other CD tools is to talk about sort of the building blocks that it works with, because I think they're really different than other CD tools. So the primitives that Spinnaker works with and that you can compose pipelines with are things like blue-green deployments, canary analysis, and one-click rollbacks. And so what's sort of the relationship between Armory and Spinnaker? Armory is really enterprise-grade Spinnaker, so really the features, support, and security that sort of enterprises need to be successful with Spinnaker. We're super excited about our upcoming SaaS offering. We have a sort of couple different ways you can get sort of our enterprise distribution. You can install it yourselves. We'll manage it in your environment, and soon we'll be able to have sort of a fully fledged SaaS offering. And we also sort of work in open source. We're in it for the long haul. We work in open source to make sure that the project is healthy. Cool. I'm going to turn it over to Praneet to talk about Pulumi. But also, if you guys have any questions, feel free to ask them at any point. We're happy to answer them.
Great.
Great.
All right, can you still hear me okay? Perfect. All right. So, so as Dan mentioned, I'm here to talk about Pulumi. Pulumi is a modern infrastructure as code platform. I think of it as a platform because it combines several things. The ability to write infrastructure using general purpose programming languages, and there's a CLI that lets you run those apps that you write. As well as there's the SaaS offering that allows you to kind of get this 10,000 feet overview of everything that's going on in your organization as far as infrastructure goes. So it's a great place to go see what's going on with your infrastructure, get the full traceability of all the changes that have happened with regards to a specific stack or whatnot. And if you're unfamiliar with the terms, don't worry about it. When you check out pulumi.com/start, we'll explain all of those concepts to you. But briefly, as the slide here mentions, there's a few things that makes Pulumi really special. One, because we're dealing with general purpose programming languages. That means that you can also do things like, normal code reviews, and you can write tests for it. You can integrate it as part of your continuous delivery workflow, which is what we're here to talk about today. But really, anything that you can do today with your application code, the code that runs during runtime, we're trying to change the thinking of developers and ops teams to also treat your infrastructure the same way, right? If you're continuously testing your infrastructure and you're continuously deploying or updating your infrastructure, why not do it through a pipeline and automate all of that, especially allowing your dev teams to also be able to move in an agile way and be able to quickly offload things rather than having to go back and refresh their memory on how a certain infrastructure was implemented and whatnot. It's really easy to pick up and start. And so it really helps eliminate those silos that exist between the various ops teams and the developer teams that work on the application itself. I mentioned that Pulumi supports some popular general purpose programming languages. There's one of the examples that we like using that we think resonates with most of our audience is being able to create an S3 bucket with AWS. As Dan mentioned, Pulumi is able to let you create infrastructure across various cloud providers, which we'll see in a couple slides later. But basically, when it comes to creating a resource in a specific language, we're not trying to reinvent how you go about creating those resources. We're basically whatever knowledge that you have working with a specific programming language or just even any general purpose programming language, really. It's easy to pick up one of these languages and start creating your infrastructure in that programming language. So for example, if you're used to writing apps and using the Node.js runtime, then you're probably using Express and you're using the whole Node ecosystem and pulling in a bunch of NPM modules and such. The experience of writing infrastructure using Pulumi and Node.js would also be the same. You're basically going to be able to use the same NPM modules, any libraries that you have been used to using. You can still use that. You can still make calls out to other tools as part of your infrastructure. If you need to, fork out to another process that needs to do something, basically you can do all of that. So really, we're opening up the gates to what you can do with the programming language for the infrastructure space as well. And I mentioned about deploying continuously and being able to use the existing workflows that you have for your application, also for infrastructure. So, we've seen users use any of these VCS to several CI/CD systems. In fact, we actually have guides covering how to use Pulumi in all of these CI/CD systems today. We also support writing infrastructure in any of these major cloud providers, but that's not all. We actually support over, I think, a few dozen, probably 40 plus providers, which we'll take a look at that momentarily. But today we're going to talk specifically about Spinnaker, and I'll show you how to install the plugin, the Pulumi plugin for Spinnaker with just 2 simple commands, and how you can get started using Pulumi and Spinnaker. As I mentioned before, there's over 40 plus infrastructure providers, really. Just looking at all the logos here, you can, some of you out there probably wondering, oh, I could automate pretty much my entire infrastructure stack using programming languages, and you won't be wrong. We've seen teams go from nothing to completely reinventing their infrastructure with just programming language and just really do it very quickly, because you're basically going to reuse your existing knowledge of how these providers work or how you've been working with them. And that's not to say, the development environment also, pretty much just like how you're used to writing your application code using any of the IDEs that you may be used to using. You can use those same IDEs. You get the same strong typing support with many of the programming languages that we support, and as well as just being able to integrate that into your local development loop itself. And like I said, we definitely support the top or like the big cloud providers, but there's so many other cloud providers out there, including DigitalOcean and Hetzner Cloud and whatnot that we support as well. So really, you should go and take a look at all of the cloud providers that we support, and then get started automating them today. So I wanted to show a quick demo of how to install the plugin itself, and we actually have the plugin in a repository today. It's open source. We've been working with Armory, and I specifically have been working with Daniel Peach, on this plugin itself, and using the new plugin framework that's being developed for Spinnaker. So if you haven't checked that out, you should definitely check it out. But basically, there's just two simple commands. One is you add the repository that the plugin is going to be sourced from, and the other one is to actually install the plugin itself. Now, I'm not going to run these commands because I've already gone ahead and done that, but I just wanted to show you what these commands look like in a terminal. Basically, I'm adding my Pulumi repository that contains the path to the repository JSON file that's like a metadata, and the second one is actually adding a specific version of the plugin itself. So if I take a look at my Halyard config, you can see that the repository gets added. As you can see, I have my own repository here, and that's because you can have other repositories in your Spinnaker or your Halyard configuration. So you could imagine, pulling plugins from different repositories because you would like to use some custom stages that are provided by different plugin authors and such. So you can totally do that. It's kind of like, similar to some of the plugin experience of other CI/CD services where you can add whatever community authored plugins to enrich your experience of using the CI/CD service. And you can see under the Spinnaker extensibility, the plugin that I was adding using that second command. So that's pretty simple, just two commands to get started. So I also wanted to show how to use the plugin itself in Spinnaker. It's pretty simple. I have a very basic pipeline here. I won't go through too much of the pipeline because Daniel's going to do the deep dive about doing the continuous delivery using the plugin and showing an awesome pipeline there. But when we designed the pipeline, we wanted to keep in mind that users would want to use their own, may want to use their own Docker container that has some specific ways to pull cloud credentials and whatnot. You can definitely do that. If you don't know if you want to do that, you can definitely leave the default, which I think is Pulumi latest, which gives you all the tools that you need in an environment to be able to run the Pulumi app itself. And we expose some other things such as, which command you would like to run, what are the arguments that you want to pass to that command. And this basically maps directly with the commands that the Pulumi CLI itself exposes. And there's this curious thing here, actually, these two things. But first, the backend URL itself is the default managed service backend that we provide, and this is our SaaS platform that you can use to manage your your stacks, and you can control RBAC for all of your stacks. So if you have a team and you only would like to give access to specific members of your team access to the production stack, then you basically that's the place where you can do this. But of course, there's also the option to self-host Pulumi. So if your organization is interested in self-hosting Pulumi, then this is where you would change the URL that the CLI will talk to in order to keep track of the infrastructure state. That's one of the really beneficial things about using something like Pulumi. You get infrastructure state tracking out of the box. So really you can, when you start today, when you go sign up for an account, you start today. If you're not using it already, you by default, you're getting that. Basically we track what infrastructure you've already deployed. And then when you make changes, we tell you that, hey, you're changing your, resource XYZ, and we have to delete it because you changed property, DEF or whatever. And so we show you this really rich diff right in the CLI. And as well as, because we're using the Pulumi plugin, you can see the console log output here also. And then the last thing is secrets. So your Pulumi app will need access to the credentials to your cloud provider, so you can actually go out and create those resources. And so the secrets name is a Kubernetes resource secret, or secret resource, sorry, that contains environment variables that your Pulumi app needs access to. So in a multi-team setting, you can think of Spinnaker admins basically creating these secret resources for you and only giving access to a specific secret to a team, and that therefore only that team can use the environment variables and hence the credentials to a specific cloud provider itself. So that's pretty much what the plugin does. It's really powerful. Like it exposes all of these functionalities of what you would be able to do on your local machine with the CLI, and really allows you to customize this in a way that your team needs to. And like I said, if your organization is interested in creating its own Docker container image, or an image that pre-bakes a way to pull cloud credentials or package some other tools, you can absolutely do that as long as your Spinnaker cluster can pull that image down. You can specify that image here and run your Pulumi apps within that image itself. So that's a really nice option for some advanced use cases as well. But with that, I will actually pass it over to Dan to take us through some. Oh yeah, sure.
Just a question for you. So if I wanted to sort of know more about installing and configuring the plugin, where's a good place to look? Is there documentation?
About the installing the plugin itself?
Yeah, or sorry, I thought there was a site under Pulumi.com that gave you sort of the configuration options and
no, that's a great question. Yeah, so there is. We actually have a whole section about continuous delivery tools, and this is a section that I actually referenced in one of the slides. And there you go. There's the Spinnaker guide that walks through all of the Spinnaker concepts. Of course, it doesn't do a deep dive into Spinnaker concepts, but touches on a few of them, and as well as some Pulumi concepts as well to get you started really quickly. Yeah, you should definitely check out this guide on the various options that the plugin provides. But yeah, you can the installation method is pretty simple, but to know what customization options you have, the guide is a really good place to start. That actually reminds me, I was actually looking for the Spinnaker examples for plugin, and if I'm not wrong, there's a plugin repository. Yeah, Do you want to talk about this one?
Yeah, I can talk about it briefly. Just if anyone's curious, I know a lot of people are new to Spinnaker on this call, but I work at Armory on a team that's just generally interested in making Spinnaker more extensible, and that includes sort of this plugin framework that Praneet used to make his plugin. And this sort of actually organization, Spinnaker plugin examples, is a bunch of really templates and examples for how you could get started building a plugin for Spinnaker. And there's a ton of reasons why you might want to extend Spinnaker, but if your sort of organization has, I don't know, an internal service that, you know, the open source community really wouldn't be able to use, but you want Spinnaker to talk to that service, that's a really great way. A plugin is a really great way to enable that kind of functionality. And then the other side of that is if you're a tool like Pulumi, of course, and you want to integrate with Spinnaker, but want to have sort of a fast development cycle and not sort of have to deal with committing to the big open source community, a plugin's a great way to go. Cool.
Yeah, no, that's awesome. I remember going through these examples quite a bit when I was trying to learn and understand the concepts of Spinnaker, especially like the plugin creators guide. Although it touched on some things and I was able to kind of quickly understand, you know, the gist of how to write a plugin, the examples really helped me out. So I was really thankful for having the examples there. All right, I will give the presenter rights back to Daniel so we can go through the deep dive of the demo that we've got for you today.
Cool. Yeah, so we're going to actually show sort of the plugin that Praneet wrote in action. At a super high level, we're going to make a code change, deploy it to an ephemeral QA environment with Pulumi, with the Pulumi plugin. We're going to QA it. If we like it, we're going to deploy it to prod. If we don't, we're not going to deploy it to prod. And once we're done, in either case, either sort of branch of the pipeline, we're going to tear down the QA environment so we don't waste resources. Cool. So, so I set up a really simple GitHub repo to sort of get this working. And the repo has two components, an infrastructure directory and a source directory. The infrastructure directory is your Pulumi app, so you'll recognize this. And it's pretty simple. We're going to be deploying, our QA environment is going to be Kubernetes, but of course it could be, you know, whatever provider you want that Pulumi supports. And we're just going to be deploying a few things, so a namespace, a load balancer, and a deployment. And the namespace is going to be parameterized by the Pulumi stack, which we'll be able to pass in from Spinnaker. Cool. And then on the other side of this, we have a really simple Spring Boot application. I just took a starter app. And the change that I've made, we're going to sort of skip ahead, fast forward through the demo, but instead of saying greetings from Spring Boot, we're going to see in our QA environment that it says, hello, Pulumi. And then the sort of last thing that's going on in this GitHub repo is that when I sort of commit a change and then push a tag to this repo, we start off a GitHub Actions workflow that builds the application and builds a Docker image and pushes it to a Docker image registry. And so at that point, that's where it's sort of Spinnaker hops in. So right here, this is sort of the pipeline that we're talking about. And I already sort of committed that change, pushed up a tag, and the GitHub action ran and created a Docker image earlier today, about 45 minutes ago. And so it's waiting here for a manual judgment. And of course, you can think about this as a stand-in for like much more sophisticated testing here. So you could have integration testing, Canary analysis, some of these stages that come out of the box for Spinnaker. So before we click yes here, and we'll talk about what's going on here, I'm just going to walk through the pipeline configuration, what's going on. So for those that aren't familiar, Spinnaker has this concept of triggers, so triggers trigger pipelines, and there's a lot of sort of different things that can trigger pipelines. And one of them is Spinnaker can sort of listen to your Docker image registry and trigger a pipeline when it sees that there's a new image available. So in this case, our GitHub action pushed up a new image to this repo, and we kicked off the pipeline. So here, this stage is using the Pulumi plugin that Praneet talked about. And so a couple interesting things to say here. One, we're passing the stack as QA. Another piece is that Spinnaker has sort of this template language or parameter language. And we can say we want to pass the tag that came in from the Docker image to Pulumi here. That's how it's resolved. Next, we're sort of asking Kubernetes to tell us what did Pulumi deploy in the previous stage, and we're hoping to make this experience a little bit smoother in future iterations of the plugin. But basically, we need this stage in order to get this follow-on stage, which gives you the nice sort of drop down that we'll talk about later on. But we're going to be able to click a button, and it's going to pop open the actual controller endpoint that we saw earlier that should say hello Pulumi, as I mentioned. So here's that template language again, and it's just saying from sort of the resolved deployment endpoint stage, what's the IP that you resolved? Cool, and so in this manual judgment, you can either click pass or fail, and we can affect the behavior of downstream stages accordingly. So in either case, whether it's a pass or a fail, we're going to tear down the QA environment. And this is actually sort of just kicking off another pipeline. And we can look at that in a second, but it's really just going to be running the Pulumi stage and a Pulumi destroy. The other side is if we said pass, then Spinnaker has a notion of like flow control. And you can say, based on that expression language, what happened in an upstream stage, if it was a pass, if we mark it as a pass, then we're going to run this stage. So if we mark pass, we're actually going to deploy to prod. And again, this is kicking off sort of another pipeline. We call it a child pipeline. And we're passing, again, this parameter, the Docker image that we triggered the pipeline with to the child pipeline. Cool. So I think these two stages are really very simple. They're just, one is running Pulumi destroy. This is the teardown QA pipeline. And this one is the deploy to prod pipeline. And again, pretty simple. It's just Pulumi up, but the environment is different. Cool. So we've executed sort of the deploy to QA. We resolved the endpoint, and now we're going to actually check that this is working as expected. And great, it is. It says hello Pulumi. Cool. So now we get to say yes, it passed. And in a moment, yeah, great. So the two sort of downstream stages, which are actually child pipelines, kick off. And so this one is going to be tearing down the QA environment, and pretty soon this sort of QA, the endpoint that we resolved is going to be gone. And the other one is deploying to our prod environment. Great. I'm going to hand things back over to Praneet so we can finish this off.
Great. So before we talk about the testing strategies itself, I actually have a question. You mentioned the Docker registry. Is there a way to plug into other image registries? And like, what other types of triggers could one use? For example, if I have a CI job and I just wanted to kick off a build or a pipeline in Spinnaker, could I do that somehow?
Yeah, so we have there's first class support for like a bunch of different CI tools. So like Travis or Jenkins. Jenkins is really one of the oldest and primary ones. And sort of those triggers, so you can say like on the completion of this Jenkins job, kick off this pipeline, and you can sort of pass references to like the artifacts that you want to deploy between Jenkins and Spinnaker. But something that's happened in the past couple of years is this triggering has become more generalized. And so if you just want to send a webhook with sort of references to what you want to deploy, or we have support for like SQS or Google PubSub. And so you can really sort of build the triggering flow that you want based on sort of these PubSub tools or webhooks and so on.
That's cool. I didn't realize that there was PubSub triggers also. I could imagine creating that PubSub infrastructure itself with Pulumi and setting that up for use with your Spinnaker pipeline. That'd be a cool thing to do. Awesome. So I wanted to talk about testing strategies. I don't think I can cover all of the amazing things that you can do with the various strategies that Pulumi has to offer with infrastructure testing. I definitely urge you to check out the testing guides for examples on each of these strategies, and just kind of give you a starting point for how you can use this or any of these strategies to test your own infrastructure. So because Pulumi allows you to use programming language, you might be wondering, could I then test it just like my application code? And yes, you can. And there's also some nuances about infrastructure itself, right? We're creating infrastructure resources, physical or like actual cloud resources that do a thing. And so in the simplest case, we have unit tests where you can mock those resources and then you can do some really basic testing. So if you were, for example, using the TypeScript or JavaScript language, you can use Mocha tests. You can write a test using Mocha test framework and run really quick unit tests for simpler things. And if you want to do some more advanced things, such as enforcing policies and such, which I touched on very lightly before, but it's a really powerful tool, especially for organizations, but not just organization, but any other team that wants to enforce security policies and such. You can definitely do that with the policy tests. But one really simple example that I like to use is just the requirement to tag resources for cloud. It becomes really a thing that pretty much every team wants to do. Once you've started using cloud services and you've grown a little bit and you start to add more cloud resources, there's usually a desire to tag those resources. So for cost control, but also for B, to see why certain resources are being created, and just so that you don't have zombie resources out there that are just churning and and contributing to that cost control thing that I mentioned. And so you could imagine writing a policy test that ensures that your teams are when they are creating infrastructure resources, that these tests will run at the organization level and check if those resources have a tag. And if not, then you can either set that to fail the deployment or you can warn them. And so it gives you the ability to kind of turn the knobs based on what your organization policy is. And lastly, the integration test itself. It's a really good way for you to automate the whole end-to-end of setting up your infrastructure, and then just validating that your infrastructure runs, and maybe run some smoke tests as part of that, and then tear it down. So that's completely possible as well. And of course, again, just using programming language to do that as well. And I definitely urge you to check out the testing guide and look at the examples and write tests for your infrastructure. It's really very easy to get started. But with that, that's pretty much what we had to discuss today, and show you a couple of demos about the plugin and a sample continuous delivery pipeline. Here's some helpful links for you to get started, and specifically for Pulumi, we do have some really nice tutorials on our Get Started page. It introduces you to a lot of new concepts, but in a very simple way, and so you can get started with Pulumi fairly quickly, actually. So understand concepts like stacks and projects and whatnot. Other than that, Dan, I don't know if you have anything to add about a good way to get started about Spinnaker itself.
Yeah, there's great docs on Armory.io, the link there. There's also sort of the general open source website, Spinnaker.io. Both places are good places to look.
Great. I actually remember just now, I know when I was trying to set up Spinnaker, I definitely was trying to go through the setup guide, and I found that there's a lot of steps to do to get it set up right. The one thing that really helped me out personally was the Spinnaker tool that you guys have put together, which was super easy to get started with. And I had a local cluster up and running in like 15 minutes or so. And then from there on, it was super easy to just quickly test the plugin when I was developing the plugin itself. So if you're looking to get started to use Spinnaker and want to, just take it for a test drive on your local machine, I definitely recommend checking out Armory's Spinnaker tool as well.
Yeah, I appreciate that call out. Yeah, Spinnaker is, it's not like Pulumi, which is this really easy CLI to get started with. Spinnaker is a bunch of microservices, and sort of getting that up and running in a single command or set of commands is not as easy as Pulumi. So Spinnaker is a great tool. So yeah, appreciate that.
So yeah, it does. If you have any questions, please feel free to submit some questions, and we'll be happy to answer those.
I have a question about the testing, and if someone from the audience has questions, they can interrupt at any point. But how does sort of the policy testing works? Like how do those policies get like distributed through an organization? Like what form does that take?
Yeah, no, that's a great question. In fact, let me see if I can open a I'll go to the very guide that I've been asking folks to check out. So we also refer to the policy test as policy as code, but let's go check out some examples here. So basically, the way this works is, you author your policy as code, and and here's a very simple example. It's a policy that is validating the cluster resources. Just reading this on the fly, but you can see that it's pretty simple. You know, it's kind of follows the pattern of a unit test, where the unit test is validating a specific artifact, and in this case, this validate stack callback is past the resources that are being constructed, and so you can basically evaluate certain properties about the resource based on the value of the properties, and you can either report an error and control basically the violation level with the sort of enforcement that you want to put on that policy. But you know, this is a very quick example of you know what a policy itself looks like. So basically, you've got your infrastructure code, and then you've got the policies, and they're independent of each other in terms of where they live within the code base. But as far as publishing the policy itself goes, there's a separate command that you would use to publish that policy to your organization, and so the policy gets stored as a policy pack, as we call it, and you can version those, and you can control enforcement of those policy packs either for all the stacks within your organization, or you can enforce them for specific stacks, and you can do that through the Pulumi console. And so when you run when you run your infrastructure code itself, you can specify which policy pack to run. But also when you're enforcing it for all of your stacks, when you run Pulumi up, basically that will pick up the policy pack that it needs to run.
Got it. That's really cool.
So I see a couple of questions here. So I'm actually not super familiar with the Spinnaker Canary deployment method, but you know, speaking just from the Pulumi perspective, you know, I would say if using Pulumi to orchestrate the red, green, or whatever deployment strategy works for your team is easy and manageable for your team, then I would say that. But I don't know, Dan, if you have something to add about contrasting between, you know, using Spinnaker to do the Canary deployment versus using Pulumi itself.
Yeah, I'm curious what sort of a Canary deployment with Pulumi means, because I think you know, different sort of tools have different notions of canarying. You know, there was a tool, Istio, which many people are familiar with, which you know, said it had canary support, and really what it was talking about was like the ability to sort of do like traffic management at a very low level between multiple versions. And for Spinnaker, the integration is really saying like Spinnaker is integrated with a bunch of sort of metrics providers, so Datadog, Prometheus, et cetera, et cetera, et cetera. And if you give sort of Spinnaker, or actually sort of Spinnaker's Canary analysis service is called Kayenta, and the idea is that you give Kayenta two labels. One is like the old sort of deployment, and one is the new, and a time range. And Kayenta sort of asks those metrics providers for the metrics over that time range, and does like a statistical analysis of the metrics across that range, and comes to like a yes or no judgment. So that for Spinnaker is what we mean by canary analysis. And so I'm curious, sort of, it says both Pulumi and Spinnaker have the ability to canaries. What does a canary look like in the Pulumi world?
Yeah, in the Pulumi world, I think depending on what sort of resources you're deploying, managing the switch between the traffic can like you will have to employ an explicit strategy to code that rather than having a higher level tool that can manage that, such as in the case of Spinnaker. So I know that we've done some work on an operator for Kubernetes specifically, which would allow you to do such a deployment strategy. And I don't know, I know Mike has been, Mike is on as well. So I don't know if Mike, you have something to add here as far as like the operator goes and how you could use Pulumi as part of that to do a blue-green type of deployment.
Yeah, it's a great question. So to take a step back for a second, the way Pulumi works in general with resources is in a create before delete approach. So by definition, all resources in Pulumi in their dependency graph are blue-green out of definition. Now, to Praneet's point, things get a little bit more tricky once you start involving service traffic and making sure you don't have dropped packets. So that comes down to making sure that you're going to do a little bit more orchestration depending on the platform you're using. So in Kubernetes is a good choice where blue-green deployments are naturally supported if you're using stateless services that are fronted by a service selecting on labels. That can be facilitated in a series of steps with Pulumi. But generally speaking, when it comes to true service blue-green, it's always going to be a little bit dependent on how it is you're rolling it out and the platform that you're working with. But again, by definition, the way we create and replace resources when, say, their specs change, like if you have an S3 bucket and it's a public setting by default, if on the next run you want to make it a private bucket, we will create that private bucket first, make sure it's responsive, it's up, and only until we know we have complete success, then will we tear down the previous S3 bucket that was private.
Yeah, and speaking of specific platforms, Azure has some services to that have that capability sort of built in. App Service is one popular one that supports deployment slots. So you deploy to, the idea is that you deploy to a staging slot, and then you have your live site running in the production slot. And then they have this feature that allows you to swap the slots. And you can also, and I don't remember if they have a way to direct traffic to both slots and then do an intelligent swap. But again, like as Mike has also pointed out, it's really dependent on what type of platform that you're trying to deploy to, and what you'll need to work with. So that can get a little bit tricky with Pulumi. Cool. I don't think we have any other questions for today. So I guess we can end the webinar for today. But Dan, it was really great talking to you about this and showing off the plugin and going through the pipeline as well. So
yeah, it's been great.
All right. And thanks, Mike, for participating and helping with all the questions. And thanks, everyone, for joining. We'll hope to catch you on the next one.
Great. Bye, everyone.
See you all.